With mini splits, it's often difficult to figure out the exact capacity or how many BTUs they're producing because of the nature of an inverter-driven system to constantly ramp up or ramp down. Now there are a couple tricks we can do. Sometimes we can place the unit into a test mode, which will give it a false set point, a very low set point, or we could lower the set point as low as we can. And the unit will ramp up, but it will not ramp itself into a range where it's unsafe. But if you want to see if it's actually performing, you can utilize a little piece of formula that we learned from the psychometric chart to calculate total heat without even having to use a set of gauges. To do that, we're going to use a formula called the sensible heat formula. And what we're going to look at is the CFM being exhausted by the condenser fan motor, the temperature difference of the air going in and out of the condenser, and then we're going to use a formula of timesing it by 1.08, which is the relationship between specific heat and specific density of air. To do the total heat of rejection formula, the first thing you need to do is measure the diameter of the opening of the condenser fan to make sure you know what size it is. We're going to use this with our anemometer. So I measured this out earlier, but it comes right out to about 21 inches. Now the key is to measure just the opening of the shroud, not the diameter of the plastic housing itself, as it's larger than the opening. So again, as we measure the opening of the shroud, we came up with right about 21 inches. Now there's lots of different tools you can do it with. I happen to like this anemometer. It's digital and it Bluetooths to my phone, and it incorporates an app. The beautiful thing about the app is that it'll do the calculation to transfer the velocity in feet per minute to CFM based on the area of the circle. So to do that, I'm going to open up my app. And the first thing I'm going to do is push the power button on the anemometer to pair it. Now the next thing I'm going to do is do a test called volume and velocity. So I'm going to select that. I'm going to tell it which type of ductwork it has, either rectangular or circle. Since this is an opening for the condenser fan motor, it's obviously circular. In here I put in the inches, and you can see here that we put in 21 inches. Then we're going to start the test, and all we're going to do is traverse the opening of the condenser fan motor, or slowly move the anemometer across the condenser fan shroud to get an average CFM. So to do that, we're going to press Start Test. And now as I move the anemometer across, at a slow rate, you'll be able to see the different CFMs that we see as we go across the circle. You will notice on the inner, there'll be a lower volume than there is on the outer edges. And we're just going to keep traversing this until we've covered each area of the fan, obviously not measuring the center or the circle. Now you can see that our CFM is 945 across that condenser fan motor, and we can simply go to our calculator. We'll take the CFM of 945 times the temperature difference we measured of about 10 degrees times that factor of 1.08, and it'll tell us that currently this 12,000 BTU condensing unit is running at about 10,206 BTUs. This could be because it's starting to stage down as we get closer to set point, but this gives you a rough idea of the BTU rejection that's taking place. If the number is dramatically off, you can start to investigate a little bit more to see if you have a system problem that may be airflow or refrigerant related. Thank you.
For service manuals and other documentation, please visit our website at samsunghvac.com or use our Samsung HVAC mobile app to download any technical documentation. Thank you.